It's a blast from the past. We haven't done factoring in a long time. Okay, there's different kinds of factoring, so we might want to take a quick look at them to help us remember how we factor things. It all depends on how big the problem is. Okay, if you have the different factoring methods, the first one we learned, well, I don't know, you tell me. Name me, so give me some factoring methods. Star, very good. I heard another one. GCF, okay, anybody else? That doesn't factor. That's a different split factoring, okay, or group factoring. All right, so let's talk about GCF first. All right, GCF factoring. This works best when you have two terms. All right, so it's going to look something like this. If you've got a squared minus ab, that is two terms. You'll be like, wait a minute, there's like an a squared and an a and a b. Aren't those three things? No, the terms are the chunk in front of the subtraction and the chunk behind. That's what we mean when we say that there are two parts to that. When you have two parts, the best thing is to look for a GCF to see what they have in common. This clearly has the variable a in common, which leaves you with the parentheses of a minus b on the inside. How do you check a GCF to make sure you've done it right? You redistribute. Okay, so number 2. Then came our star factoring. Star factoring was when we had 3 terms. Okay, 3 terms would be then addition and a subtraction, or 2 subtractions, or 2 additions, or something like that. So you might have a 3a squared minus a 2a minus a 1. That would be an appropriate time to use star. We call those, there are 3 things separated by 2 subtraction signs. And so just to review how star goes, okay, we make sort of the X over there, and the top of the star is coming from the outside 2 numbers, the first and the last number, so it would be the top of the star. Okay, and then the bottom of the star is going to be -2, and then I'm trying to find 2 numbers that both multiply to make the top, but add up to make the bottom. All right, can we think of what that might be? -2 and -1 aren't going to multiply to make -3. Okay, so I'm going to want -3 and 1. Is that going to work? 1 and -3? Okay. What do I do with those 2 numbers now that I have them? Yeah, that's tempting. That's tempting, but that'll, okay, so we're going to have to do 3a squared, and then after that's going to come the 1. So the 1a, that's coming from the number 1 right here. And then next would come minus 3a. That's coming from the -3, and then we end up with -1. And then we do what Ella was talking about splitting it down the center. Okay, the split and group factoring. So we look at the first 2 parts on the left, and what do those 2 have in common, just the 2 of them? An a. That leaves me with 3a plus 1. On the flip side, on the far side, what do those 2 have as the only thing they have in common? -1, leaving me with 3a plus 1. If you've done it correctly, then you have 2 exact factors that match each other. So 3a plus 1 and a minus 1. And usually the purpose of doing that is because the problem was set equal to 0. And we take each of those pieces and individually set them equal to 0. So 3a plus 1 would be set equal to 0 on its own. A minus 1 would be set equal to 0, and then we're in the home stretch and we figure out what a is. I don't need to do that with you by doing stuff to both sides. Okay, that is a crash course, quick a minute, in factoring. Okay, what does that have to do with the unit circle? Okay, let's take a look at solving some trig problems. They have to be set equal to 0 for this to work.
Trig.
Okay, so in trig, the power goes after the trig word, not after the variable. So it's not going to be x cubed, it's going to be sine cubed, and the x comes after. That's how you write it in trig. Minus sine x cos squared x, and that's set equal to 0. This is a 2-part problem because there's only 1 subtraction sign. There's the part in front of the subtraction, and then there's the part after the subtraction. And so since there's only 2 parts, what factoring method would be best? GCF, okay? What do the 2 parts, both before and after, have at least in common? Okay, not just an exponent, they don't have any matching exponents. So what do they have that's the same? They both have sine. Okay, we're looking for the trig that they have the same. And we're not looking for variables, we're looking for trig. So they have a sine that's the same. So let's take a sine with an x out from both parts. Now what's left in front of the subtraction sign? If I had a cube on the sign and I just took a single sign out, what am I left with? A sign with a square, but it still has an x. On the back end, what am I left with? Okay, I'm left with cosine squared x. All right, both of these are set equal to 0, so I'm going to solve them separately. So I'll take the outside sine x, which is my GCF, put it equal to 0, and then I'll take my sine squared minus cosine squared part, and that is going to be equal to 0. And then it becomes two problems in one, and you solve each problem individually, separately from each other, working on getting x by itself. So on the left side, quick, slick way to get x by itself, what do? Inverse sine. So x by itself would be the inverse sine of 0. That means the answer to that is something pi, and it's got to be the something pi on the unit circle where the sine value would already be 0. Okay, so that's 0 pi. On the flip side, on the other side, we're going to have to do a little work. How do we get x alone there when I've got two x's? Well, first of all, you want to get the x's on separate sides. What's the best way to get those x's on separate sides? Add a cosine. Okay, add a cosine squared. So that'll give me sine squared x equals cosine squared x. Once you've got them on separate sides, you want to use a division. Okay, we are going to divide by cosine squared on both sides. I'll show you. Because when I divide cosine squared by a whole nother cosine squared, what do I get? When I divide the other side by cosine squared, okay, what do I get? Well, what do I get when I divide one sine, a single sine, by a single cosine? Tangent. So what do I get when I divide a squared sine by a squared cosine? I get a squared tangent. And now we're ready to get that x alone. So when you have two x's, you want to separate them to the opposite sides and then use division. Use division so that one of the sides goes to 1. All right, how do I get that x by itself? What do I want to get rid of? Okay, do I get rid of the square first or do I get rid of the tangent first? You get rid of the square first. How do you get rid of a square? Square root. And yes, and what's in front of every square root is a plus or minus. So I've got plus or minus square root 1. Well, we all know what the square root of 1 is. That's just plus or minus regular 1. So I almost have my x by itself. And then how do I get that x alone? Now I'm going to take the inverse, and it's the tangent inverse of both plus 1 and minus 1. So I am going to have 2 pi answers. They're both going to be fractions, so fraction pi and another fraction pi. What's going to be the family of fractions where this is going to happen, where tangent is equal to 1? The fourths. All right, which particular fourth, not in the third quadrant, is going to give me the positive 1/4? Okay, and which one gives me the negative? Okay, you guys are getting that real good. Okay, any questions on that? Okay, let's try another one. I started you kind of with a tough, like on that one, I guess, one of those sides was really easy and the other side was a little harder. Okay, how about this? Cos cubed x minus a plain old cos, and that's equal to 0. Again, this is a two-parter. There's only 2. So I know that I'm going to be using the GCF method. So what is in common both before and after the subtraction? Cosine. Okay, when I take the one cosine away, a single cosine away from cubed cosine, what am I left with? Squared cosine. Minus, there has to be something after. I just took all of cosine away. You're left with 1. You have to be left with something. Okay, that is equal to 0. Now we'll take each piece. Cos x, set it equal to 0. Cos squared x minus 1, set it equal to 0. It becomes 2 problems for me to solve. Quick and slick way on the left, what do I do? Okay, inverse cosine of 0. Answer is going to be some kind of pi. Okay, what kind of pi will guarantee me that cosine will have a value of 0? 1/2. That's one of the quadrant angles. Okay, on the other side, what's my quick way to work on getting that x by itself? Add 1. Then what? I do. I apply a square root. So in the same way, I'm going to have plus or minus the square root of 1, which is, of course, just plus or minus 1. Then I apply the inverse cosine to that. So x will be the inverse cosine applied to both plus and minus 1. So I'm going to have 2 pi values. I'm going to have a pi value where cosine is positive 1 and a pi value where cosine is negative 1. So let's do the positive one first. When would cosine be positive 1? Okay, how about negative 1? 1 pi. Let's try another one. All right, rad 2 cotangent x sine x minus cotangent x. Okay, it looks bad, but it's not. How many parts are there? There's still just 2 because there's only one subtraction. So it's just, even though it looks complicated, there's only 2 parts. There's a part before the subtraction and after. So there's got to be hopefully a GCF, which is what? Cotangent of x. What will that leave me with when I pull the cotangent of x out? Rad 2 sine x, that's in front of the subtraction. And then after the subtraction, 1 equals 0. So I had the part that was in front and the part that was in the back. So now I'm going to take the cotangent. What do I do with it?
Inverse it?
Not yet.
Oh,
I have to set it
sorry.
equal to 0. Yep. And on the other side, I'll take the rad 2 sine x minus 1. What do I do with that? Set it equal to 0. Okay, do you have a preference which side we work with first?
Left. 'Cause that's the
Left. All right, so get x alone. Inverse cotangent of 0. How about inverse tangent instead? If we change it to inverse tangent, what do you have to change 0 to? 1 over 0. Which you can change to inverse sine over inverse cosine. So the inverse sine is on the 1 and the inverse cosine is on the 0. So what pi position is happening where sine is exactly 1 but cosine is exactly 0? That's 1/2. That's at the quadrant angle. That's right at the top of your unit circle. Okay, let's finish up the left side. First step.
plus 1.
Okay, rad 2 sine x equals 1. Second step.
Square it. Square that.
No.
No, I'm sorry. Exponent.
I need to divide.
Gosh.
Okay, when something's in front of the sine x, I'm going to divide. So I have 1 divided by the square root of 2.
Oh, yeah.
Okay, it's not like it's a square symbol. It's
I thought
a
it was
square root of 2.
Okay.
Okay? All right, now, this goes back to last week when I was showing you some of the extra credit hints that we were giving. What's 1 over rad 2 equal to? Did you write it down last week? Rad 2 over what? Nope. Rad 2 over whole 2. Okay, I showed you that last week. That's called rationalizing the denominator. Okay? If you don't remember how to rationalize the denominator, you times the denominator by its own rad 2 times the top by its own rad 2. That turns into a rad 2 over a regular 2. Once you've rationalized, then you can apply the inverse.
Oh, yeah.
Because rad 2 over 2 is one of those places you've memorized around the unit circle that happens at what fraction family?
1/4.
Okay, and particularly at 1. Yes?
So we have to know how to rationalize.
You're going to need to recognize it. Like it might show up in your homework. I probably won't ask it on a quiz, but it is going to show up on your homework. Okay, one more, and then we're done.
Uno más.
Sí. Solamente uno. All right, last one for today. 2 cos squared x minus cos x minus 1 equals 0. Okay.
Star.
Why is it star? Why did you? It has 2 subtraction signs, which means this is divided into 3 parts. Before you do star, I'm going to recommend that you make sure all 3 parts have a number. So like in the first part, the number is 2. At the last part, the number is -1. What about in the middle? Okay, I'm going to encourage you to add the 1 there. So my star, the top of my star will be dependent on the first and the last numbers, which are -2. The bottom number would be the middle, which is -1. I think about that for a minute, what numbers would work to make that work for me. Okay, 1 and -2, or -2 and 1. All right, what do I do with those center numbers now? So I'm going to have 2 cos squared x. Then I'm going to have the middle numbers that I just came up with. So here's the 1. So I'm going to have a +1, but what do I have to have on it? Not just an x, a cos x, because I'm in trig. The next number was -2. So that'll be -2, not just with an x on it, but cos x. And then the -1, that was the last number, and the 0. So now I'm ready to split that down the center. All right, the front 2 parts should have something in common. Okay, a plain old cosine. If I take a plain old cosine away from 2 cosine that was already squared, what am I left with?
2 cosine x?
2 cosine x, and then plus how much?
+1.
Plus 1. What about on the far side? What do they have in common? A -1. And when I take the -1 away, I'm left with 2 cosine x plus 1. So what do I do with that 2 cosine x plus 1, which was in parentheses? Set it equal to 0. And what else gets set equal to 0? Cosine x minus 1 also gets set equal to 0. And then we're ready to solve. So we're going to, on the left side, we're going to subtract 1. 2 cos x equals -1. We'll divide by 2. So cos x is -1/2. We'll apply the inverse. And we'll think about the pi and the fraction that would happen to guarantee. Okay, so what's the family fraction? Can you at least get me that? That's a thirds. Okay. I need to make sure cosine is negative. What quadrant do I have to be in to make sure cosine is negative? That goes through quadrant 3. I have to be in quadrant 2. So this is going to be 2/3. All right, and then on the other side, I'm going to add 1. And so x would be the inverse cosine on 1. And what pi position will that happen at? Where will cosine be equal to 1? Cosine is the x value, so where's the x value equal to 1? 0 pi.